Yes, good morning all. I'm going to explain definite integrals. Today I'm going to concentrate more on definite integrals, the problems on JE level, definite integrals. All different types of problems I'm going to explain in definite integrals. See that only the topic is definite integrals. See here, I'm going to explain only definite integrals. All are related to definite integrals. But you should familiar with the properties in definite integrals because already the properties are familiar with you. Using the properties I can discuss all this in definite integrals. So generally main the properties we may use the main properties in definite integrals. Integral a to b f of x dx, integral a to b f of x dx equal to, I can split this a to c f of x dx plus c to b f of x dx. I can split this. I can write this into a to c, c to b. I can split. Like in between a to c, I can split. So this is one of the property we are going to use this a to c, c to b. I can split this where a less than c less than b, where a less than c less than b. That you can remember, a less than c less than b. And one more property I am going to use, integral. This is also important. I can write 0 to a, integral 0 to a f of x dx equal to 0 to a f of a minus x dx, f of a minus dx. Even this property I can also say this is a special case of this one. You can see integral a to b. I can also write integral a to b I can write this one integral a to b when I have written this integral a to b, I can write f of x dx is also equal to, this is a to b, a to b is also equal to a to b f of a plus b minus x dx. So this is also one of the property. I can add a plus b, replace x with a plus b minus x dx. So these are the one of the property I am going to use this. Another one, just remember another one related to even and odd. Even and odd, when they are talking even and odd, suppose minus a to a, remember the given integral minus a to a. When they are talking integral minus a to a, integral minus a to a, this is a, so whenever minus a to a, f of x dx always equal to this one I can write, always remember, I can write 0 to a f of x plus f of minus x. Always I can express like this dx. Whenever minus to f of x dx equal to 0 to a f of x plus f of minus x. This is f of x, f of minus x dx. Now from this I can define which is equal to, I can write 2 into. So when I are written like this, I can also write this will be equal to 2 into 0 to a f of x dx, 0 to f of x dx. If f is even, equal to 0 if f is odd, So remember like this you can express, f is even we will write like this, f is odd we can write 0. But we know that what is even and what is odd function. When I am talking about even function, suppose whenever they are talking even function, f of minus x equal to f of x. When they are talking odd function. So when it is talking odd function, just remember, when it is odd function, I can write f of minus x equal to minus f of x. Specifically in trigonometry, even function you can write cos x and secant x are even functions. And here odd functions I can write sin x, cosecant x, tan x and cot x. These are all odd functions. Only cos and secant are even functions. Just remember this property, you can remember. This is one of the property. Whenever minus a to a whole, you can verify whether even or odd. Next one. Excuse me. Next one. Another important property. This I discussed about even and odd function. When I am talking another property. So another property will be 0 to 2a, 0 to 2a, f of x dx equal to, I can also express this one, 0 to a, f of x plus f of 2a minus x dx. Sometimes the problem they make you the right hand side. This is dx. I given dx this one. So this one also again we can write, this is important here. This also we can write, which is equal to 2 into, right, I can also write this one. When I have taken this one, I can also write this expression is equal to 2 into 0 to a f of x dx, f of x dx, if f of 2a minus x is equal to f of x. Here no way connected even or odd. Replace x with 2a minus x. If it gives f of x, I should have 2 into 0 to a f of x dx. And again I get it equal to 0 if f of 2a minus x equal to minus f of x. Minus f of x. So remember all these properties are important. Minus f of x. So you should remember this. I will tell you here one more property. This you have taken 0 to 0 to a, right? Suppose they are asking only 0 to a. Same thing you can also think. So when 0 to 2a, you can observe here, when it is 2a, you have taken 0 to half of that you have taken. When it is 2a, here 0 to a. Suppose this is 0 to a only is here, I should add 0 to a by 2. Put at 0 to a by 2 half of this. If it is 0 to a means 0 to a by 2 I should consider. Same thing, in the place of 2a it comes a minus x. That way you can think, that you can write. Another one. This is one of the property, just you remember this. Next I can also discuss now integral a to b. This is one of the important, you can write x into f of x dx. Suppose the problem is like this, a to b, x into f of x dx. When the problem is like this, x into f of x, answer directly I can write a plus b by 2, always a plus b by 2, a to b f of x dx I can write. A to b f of x dx we can write. A to b x f of x dx always equal to a plus b by 2, a to b f of x dx. A to b f of x. You can write this one. When the condition also, if f of a plus b minus x equal to f of x, you should follow this. If f of a plus b minus x equal to f of x, we can do this. So whenever it happens f of a plus b minus f of x, then a to b x into f of x dx should be equal to a plus b by 2, a to b f of x dx we can write. So just you can remember this. Another one. Suppose they are given 0 to a. Same thing they are given 0 to, then you can understand here. 0 to a means replace a with 0, b with a. Suppose they are given 0 to a. They are given, see the previous one, 0 to a x into f of x dx is given. Just you substitute here the values, b will be a and a will become 0. You will get a by 2. You will get 0 to a f of x dx. 0 to f of x dx, right? 0 to f of x dx it comes. F of x dx. Then I can write here which is equal to, I can also write this one a into, because a into 0 to a by 2 f of x dx if f of a minus x is equal to f of x. Suppose replace x with a minus x. You got f of x, I can write half of this. I can, because you will get a by 2 into it comes. Like the previous property can apply. Just before this previous property you can apply. When I have taken, if whenever f of a minus x equal to f of x, here what can I write here? This is a by 2 into 2. So 2 will get cancelled. So this will become a, right? A into 0 to a by 2 f of x dx. If f of a minus x equal to f of x, that you can remember. Always that you can remember. Right. So these are all the properties, what are the possible properties I will discuss now. Next, one more important property you should use in a definite integral, Lineage Rule. That is important. So always remember the property is Lineage Rule. So that is important property, you should remember the Lineage Rule. Right. What is the Lineage Rule? Again, right. So when you are remembering the Lineage Rule, right, because I have taken this one. You write, when they are talking Lineage Rule, this is important Lineage Rule. What is the meaning of Lineage Rule? To find derivative of a particular function. Suppose d by dx of integral, they are given the function is like this. Lineage integral d by dx of, when you are finding integral, right, see here, when you are finding d by dx of integral of, if they write u of x, v of x, function f of t dt, when they are given like this, limits u of x, v of x, this is u of x, v of x, f of t dt. What do you write here? If you are differentiating integral, then I can write this one, f of u of x, upper limit I can write, f of v of x I can write, f of v of x into v dash of x, derivative of v of x, v dash of x minus f of u of x lower limit into u dash of x. This is Lineage Rule. U dash of x. You can use this Lineage Rule, where u of x and v of x are differentiable equations, or possible, where u of x and v of x are differentiable equations. So remember this. This is Lineage Rule. You should remember Lineage Rule. Don't forget about that, is important Lineage Rule. Next one. Suppose I am talking about now reduction formulae. When I am talking reduction formulae, just observe that. I am talking reduction formulae now. So what is the meaning of reduction formulae? So reduction formulae. Reduction formulae, suppose they are given in is equal to integral 0 to pi by 2 sine power nx dx, and also equal to integral 0 to pi by 2 cos power nx dx. When they are given this, then always you remember, here always I can write, then the formula I can write, in is equal to, suppose the case, then in is equal to n minus 1 by n, in minus 2, always n minus in minus 2, where n belongs to z plus, always where n belongs to z plus, in minus 2. That's the formula I can consider. But here depends upon even and odd we can follow. Suppose this in value I can also write, in is equal to, you start with n minus 1 into n minus 2, n consecutive n minus 1, n minus 2, n minus 3, and so on into one stage it comes 1 by 2. If it comes 1 by 2, end with pi by 2 if n is even. If n is even. And is equal to, you can write, if the same thing if you write I can write same thing. I can write n minus 1 by n minus 3 by n minus 2. And if I continue the same thing, and so on, if I continue this and so on, it will come 2 by 3. Whenever 2 by 3 end with 1, if n is odd. N is odd. Like this we can do very quickly the problems. I can use the concept of this. I will tell you example also here. So for example, they are given the problem now. See the example. When they are given example problem, I can write integral 0 to pi by 2. When they are given integral 0 to pi by 2, 0 to pi by 2, they are given, suppose for example, sine cube x dx. So n is odd. You can start with 3. 3 you can write 3 to 2 by 3. We got 2 by 3 in the beginning itself. Then automatically into 1. Your answer is 2 by 3. For example, 0 to pi by 2. Even cos cube x, same answer comes. I have taken cos square x. Cos square x means if we start with this 2, 1. 1 by 2 means into pi by 2 can end with this. It will be pi by 4. 0 to pi by 2 cos square x dx pi by 4. This is 2 by 3 into 1, 2 by 3. You can take it any number, right? For example, you can take 0 to pi by 0 to pi by 2. I have taken this one, suppose cos power 5x dx. You will write 5, 4, 3, 5, 4, 3, 2. 2 by 3 into 1. It comes 8 by 15. That will be your answer. Quickly you can write the answers here using this concept. You can write your answers right. In the case of sine or cos, but the limit should be 0 to pi by 2 only. You should follow that. 0 to pi by 2. Using the above formula, easily we can write that. Now, the second one, I am talking reduction formula only. Suppose when you are talking reduction formula, if in is equal to integral 0 to pi by 4, 0 to pi by 4, tan power nx dx. This is tan power nx dx. The rule is n greater than 1, minimum n greater than 1. Then, here, in this case we have in, always remember. So, whenever they are given this tan power nx dx, so whenever they are given tan power nx dx, I can write this one, in plus in minus 2 equal to 1 by n minus 1. This is a property you will write. 0 to pi by 4 tan power nx dx n greater than 1. Then in plus in minus 2 equal to 1 by n minus 1. From this I can write in is equal to, I can expand, excuse me. You can write this value in is equal to, I can also write in minus 1 by n minus 3 plus 1 by n minus 5 minus 1 by n minus, alternatives is easy to write, 1 by n minus 1 minus 1 by n minus 3 plus 1 by n minus 5 minus 1 by n minus 7 and so on. You can continue like this and so on. It comes at end I naught or I1 it comes. I naught, because you can see here what is I naught. I naught or I1 it comes. I naught means tan power 0 1 dx or I1. When I have written like this, I1. So what is I? Whenever it comes I naught, when n is even it comes I naught. When n is even, you can n is even it comes I naught. I1 n is odd. Like that you can remember. When n is even it will be I naught. If this is even, this is odd. When n is odd, it comes I ending with I1. But you remember what is I0, what is I1 value. I0 I can consider pi by 4. Always you can remember the values of I0. I0 will be pi by 4. And I1 will be, so you can remember I1 will be always I1. I1 will be pi 1 by 2 log 2. This ending value 1 by 2 log 2 it comes. Just remember this concept. Directly you can write what about tan power, what about n value n should be greater than 1. You can write that. Suppose sometime they may give the problem another way. Combination of this. That also you can remember. Integral 0 to pi by 4. Integral 0 to pi by 4. Tan power nx. Tan power nx plus tan power n minus 1 dx. The problem they may give like this. If they give like this, answer is always 1 by n minus 1. Tan power nx plus tan power n minus, not 1, they will give difference of 2. I thought no, they will give, then only it comes here. N minus 2. Tan power nx plus tan power n minus 2 is always equal to 1 by n minus 1. The combination if they give. Another one. 0 to pi by, so because this is given 0 to pi by 4, right? Suppose they are given integral 0 to pi by 2. 0 to pi by 2. Cot power nx. Remember, they may give the value, it will come 0 to pi by 2. Cot power nx plus cot power n minus 2x. Cot power n minus 2x dx. When they are given this also, it will be answer is 1 by n minus 1. 0 to pi by 2 means in terms of cot. Cot power nx plus cot power n minus 2x dx. If this is n minus 2x, 1 by n minus 1. You can remember. These are the frequently they are asking this type of problems. Right. Now another one. I can also write, because I can give example as you can see. If I give example here, I can write integral 0 to pi by 4. 0 to pi by 4. Suppose I am writing here tan cube x plus tan x, because tan 3 minus 2, tan x dx. Tan cube x plus tan x dx, they are given problem like this. Your answer is, compared with this, n is 3 here, your answer is 1 by 3 minus 1, it will be 1 by 2. Another example, suppose integral, they are given 0 to pi by 2. Integral 0 to pi by 2, they are given cot power, they are given, so cot power 5x dx, cot power 5x, they are given, you see, cot power 5x plus cot power 3x. They are given like this. So answer should be 1 by, compared with this, 1 by 5 minus 1, it will be 1 by 4. We can complete like this, right? Answer will be 1 by 4. Simple, direct you can write your answers. Just observe that. What I have written, the technique easily, you can remember, you can write that value. Always you can remember, you can write that value. So don't forget about that. You can use the simple technique to write the values here. Now, after writing this, now you can see this. Here in is equal to another formula. In is equal to integral 0 to pi by 4. Integral 0 to pi by 4, I can write secant power nx dx. Secant power nx dx. Secant power nx dx. Here n belongs to z plus. N belongs to z plus. When they have taken then, how to write very quickly this answer I can write. In is equal to, we can also write the same thing. This expression I can also write. When they are given this, I can also write this one. In is equal to, correct. You remember this one. In is equal to, this in is equal to, this is also standard problem, right? Root 2 whole power n minus 2. Always remember, root 2 whole power n minus 2 by n minus 1 plus n minus 2 by n minus 1 in minus 2. So this is the formula here to apply this in minus 2. Look into this, you can decide your answer. So you can decide, for example, I will explain one problem. They are given integral 0 to pi by 4. They are given example, you can see that. Integral 0 to pi by 4. They are given secant to the power of, they are given, so for example, they are given secant to the power 3x. For example, secant power over 3x is given dx. Now you can write root 2 whole power 3 minus 2, 1 by, you will get 3 minus 1, 2. Compare this, right? N is 3 plus you will get 3 minus 2, 1 by 3 minus 1, 2. Correct? You substitute here 3 minus 2, n minus 2 by n minus 1. So you will get I, you can see this. What it comes now? Because n is 3, 3 minus 2, it will be I1. You should find I1. What is the integral secant x dx? But I1 you know how to find it. Even if you want I1, I can continue I1, root 2 whole power. If you write I1 here, 1 minus 2 by 1 minus 1, it will be 0. I can't consider this. But we know that what is I1 here? Think about I1 I should find. What is I1 here? I1 means 0 to pi by 4 secant x dx. You can find this value. Correct. How to find this one secant x dx? So when I have taken I1 secant x dx, integral secant x dx. Here this is should remember integral secant x dx log mod secant x plus tan x, right? You apply the formula 0 to pi by 4. Integral secant x log mod secant x plus tan x 0 to pi. You find I1 value. So you apply the limit, right? You can simplify. Log mod secant pi by 4 plus tan pi by 4 upper limit. I'm applying this minus log mod secant 0 plus tan 0 lower limit. Apply upper limit and lower limit. You find this value. Though it comes now log mod secant pi by 4. You will be secant root to 2, right? Tan pi by 4 is 1. This is tan pi by 4. Secant pi by 4, correct? You know this is tan pi by 4, right? Secant pi by 4 root 2. Tan pi by 4 is 1 minus log. Secant 0 is 1. Tan 0 0. But again log 1 0. It comes log mod root 2 plus 1. Because log 1 will be, this is log 1 will be 0. You will get this is the value of I1. We can replace that. I hope you understood this, right? If you have any doubt, you can ask me in the chat box. I can explain. If you have doubt, please ask me in the chat box. I can explain. Yeah. If you have any doubt in the chat box, you can ask me. Definitely, I will explain again. I will repeat again. If you have doubt, I will repeat again. Yeah. I hope it is clear. I can explain. If you have doubt, I can explain. Right. Let me know in the chat box. If you have doubt, I can explain again. Yeah, I can repeat this. See this one. When they are given this problem, they are given, you see that formula here. Integral in equals 0 to pi by 4 secant power nx dx n belongs to z plus. In is equal to root 2 whole power n minus 2 n minus 1 plus n minus 2 n minus 1 in minus 2. When I have taken 0 to pi by 4 secant cube x dx. So compare n value 3. Root 2 whole power 3 minus 2 by 3 minus 1. You will get n by 3 minus 2. 1 by 2 I1. So when I1 I can't consider. 1 minus 1 0 I can't consider. So I1 think replace n is equal to 1. When I1 replace n is equal to 1, I1 becomes 0 to pi by 4 secant x dx. But we know that integral secant x dx is log mod secant x plus tan x. This is log mod secant x plus tan x. Log mod secant x plus tan x. Apply limit 0 to pi by 4. 0. This is applying limit 0 to pi by 4. Then upper limit secant pi by 4 plus tan pi by 4 minus lower limit. You apply upper limit minus lower limit. Right? Because this is the limit. I have taken this is the limit pi by 4. Apply the limit secant pi by 4 is root 2. Tan pi by 4 is 1. Minus secant 0 is 1. Tan 0 0. Again log 1 0. So your answer will be log of root 2 plus 1. Then you continue here. You replace I1 with log of root 2 plus 1. So integral 0 to pi by 4 secant cube x dx should be equal to root 2 by 2 means 1 by root 2 plus root 2 plus 1 by 2. We can write the conclusion 0 to pi by 4 secant cube x dx is also equal. I can write root 2 by 2. Root 2 by 2 plus 1 by 2. So I1 means I can write root 2 plus 1. Correct. That is I1 value. We got root 2 plus 1. Like this we can conclude this. Correct. I think Pawan is clear. I understood this. I have repeated that. Is it clear? Yeah, then I will do the next one. See that after this one, you got an idea about this, right? Important model only can learn this. The next one. When I am doing the next one here, again here, suppose this one. See, again, some more standard problems I can discuss the next class also, because here the reduction formulae many will be there. The values formula also I can discuss about the values formulae. I can discuss now. So values formulae, the combination I can discuss. Now before that, the standard problems I will tell you now. This one, right? Integral 0 to pi by 4. Integral 0 to pi by 4. Log of 1 plus tan theta d theta. Log of 1 plus tan theta d. They are given like this. Answer is pi by 8 log 2. Standard you can remember. 0 to pi by 4. Log of 1 plus tan theta d theta. Pi by 8 log 2. Another one. Integral pi by 4 to pi by 2. Integral pi by 4 to, if they are given. I can also discuss integral pi by 4 to pi by 2. This is pi by 4 to pi by 2. Log of 1 plus cot theta d theta. Log of 1 plus cot theta d theta. So this is also equal to, I can write, this is also equal to pi by 8 log 2. Both, remember, both you can compare this one. Both the case answer is pi by 2 log 2 standard problem. These are the standard problem you can remember. Always you can remember this. This is a standard problem. Even I can remember one more standard problem. Integral, I can also write, when they are talking, see this. When they are given this one, pi by 8 log 2. So when I written 0 to pi by 2 log of sin x dx. 0 to pi by 2 log of sin x dx. 0 to pi log of sin x dx. This will be minus pi by 2 log 2. 0 to pi by 2 log of sin x dx minus pi by 2 log 2. Remember, that is the most important one. The concept is minus pi by 2 log 2. Even I can also write integral 0 to pi by 2. Integral 0 to pi by 2 log cos x dx. There is no change. Answer is minus pi by 2 log 2. Integral 0 to pi by 2 log of cos x dx. Integral 0 to pi by 2 log of cos x dx also equal to minus pi by 2 log 2. Because we know that 0 to pi by 2, that means 0 to pi by 2 log of sin x dx is also equal to 0 to pi by 2 log of cos x dx. Log of cos x dx. Right. You will understand this log of 0 to pi by 2 log of cos x dx. So that is the formula I have written. 0 to pi by 2 log of sin x dx minus pi by 2 log 2. 0 to pi by 2 log of cos x dx is minus pi by 2 log 2. Both are equal here. That you can remember. Both values are equal here. That concept you can remember. 0 log cos x dx minus pi by 2 log 2. Now, after writing this, we can also write integral 0 to pi by 2. Integral 0 to pi by 2. 0 to pi by 2. Log of tan x. Log of tan x. Because they are all standard problems. Log of tan x dx. 0 to pi by 2. Log of cot x dx. Log of cot x dx. And considering this is a log of cot x dx. So you can expect this is a simple problem. When these two cases answer is 0. 0 to log of tan x dx, 0 to pi log of cot x dx equal to 0. So these are standard problems. Just remember, answer directly you can write zeros for this case. Suppose the combination again. See another formula now. The combination of sin and cos. Integral 0 to pi by 2. These are most frequently they are asking in KCET exam. In CET exam or Jee Main, see here. Integral 0 to pi by 2 a cos x plus b sin x by a cos x plus b sin x by cos x plus sin x. They given only cos x plus sin x dx. You observe here 0 to pi by 2 a cos x plus b sin x by cos x plus sin x dx equal to, answer direct I can write pi by 4 into a plus b, pi by 4 into a plus b. Direct you can write this. For example, you think about that value. Suppose when I am talking about example here, integral 0 to pi by 2. I have written this one 2 cos x. You can see that value depends upon this. I can write whatever a and b, I can write anything. I can write 2 cos x plus 3 sin x by cos x plus sin x. So it is not necessary positive only, negative also you can consider. I can consider dx. This will be pi by 4 into 2 plus 3. One answer will be 5 pi by 4. That's the purpose of this. This easily you can write this 5 pi by 4. The combination of sin and cos and sin. Similarly, the combination of tan and cot. I can write integral 0 to pi by 2. Think again same thing. Integral 0 to pi by 2. I can write a tan x plus b cot x. A plus b cot x by a tan x plus b cot x by tan x plus cot x. I can write tan x. You can write this one. Right. A tan x plus b cot x by, I can write tan x plus cot x. Tan x plus cot x. So when I have written tan x plus cot x dx is also equal to pi by 4 into a plus b. Similar I can do this. Pi by 4 into a plus b. Same thing. Example is simple. I can consider any value. I can do that. It comes directly to the problem here. A tan x plus b cot x tan x plus cot x pi by 4 into a plus b. Similar I can also write 0 to pi by 2. 0 to pi by 2. Combination of secant and cosecant. A secant x. A secant x. B cosecant x by, you can write A secant x, B cosecant x. A secant x, when I have taken, right, they are given A secant x, B secant x, A B secant x by secant x plus cosecant. I can write this one. You can write this one when they're talking combination here. Right, you can write this A secant x plus B cosecant x by secant x plus cosecant x. Only you can write the combination. You can write this one. Right. A secant x plus B cosecant x by secant x. I can write here secant x plus cosecant x dx equal to pi by 4 into a plus b. Combination of secant and cosecant. It comes pi by 4 into a plus b. So this also you can write another set of formulae which is frequently they are asking. You can see another set of formulae. This also you can see now. Integral 0 to pi by 2. 0 to pi by 2. F of sin x by, this is f of sin x by f of sin x plus f of cos x dx is equal to, answer you can write pi by 4. It will be pi by 4. So when I am taking example here, see when I am talking about example in this place, when I am talking example here, if I take example, see what is the example that they are talking about example here. Suppose when I am talking an example in this place, see you take what is the meaning of this, in what way I can consider this. So if you take 0 to pi by 2, they are given for example sin power 3 by 2x, sin power 3 by 2x by, they are given sin power 3 by 2x, cos power 3 by 2x dx, they are given like this. Then answer is pi by 4. This is the meaning of that, f of sin x. Even it's f of cos x also, either sin x or cos x, answer will be same. They can, instead of sin x, if they give cos x, answer will be same. There is no change. That also you can remember. Integral 0 to pi by 2. F of, they are given cos x by f of sin x plus f of cos x. They are given f of cos x dx. This is also pi by 4. Denominator will be same. Numerator f of cos x or f of sin x. Answer is pi by 4. Same example I can consider that. You can understand this, right? So for example, if I take an example I have written here. 0 to, when I have taken an example here. See here. If I have taken an example 0 to pi by 2. They have written like a cos power 7x or cos power 77x by sin power 77x cos power 77x dx. Answer is, it will be pi by 4. We can write directly. So there is no change. Whatever the power, answer is pi by 4. Similarly, I can also write 0 to pi by 2. 0 to pi by 2. F of tan x by f of tan x plus f of cot x. F of tan x plus f of cot x. This combination also it gives pi by 4. No, it gives pi by, this combination gives pi by 4 only. Even tan x or cot x, if we replace, the answer will be pi by 4 only. In the place of f of tan x, if we replace, you can see integral 0 to pi by 2 f of cot x. They given f of cot x by f of cot x plus f of tan x dx. Answer is pi by 4. So the combination of tan and cot, pi by 4. Like, because you can write directly your answers pi by 4 only. Even secant and cosecant combination, integral 0 to pi by 2 f of secant x. This is f of secant x. F of secant x by f of secant x plus f of cosecant x dx. Answer, this is x, cosecant x. Right. Answer is pi by 4. Because the example not required, you can understand this. These are all standard problems, right? Directly you can write this. Integral 0 to pi by 2 f of cosecant x dx. F of cosecant x by f of cosecant x plus f of secant x dx, pi by 4. So these are all one set of formulae. Directly you can write answer all the combinations right. So you can write directly, you can write your answers right now. So the combinations I have discussed now. So you can remember to solve the problems frequently we can use these are the combinations. Now I will discuss another two problems like this. After that I will start doing the problems now. Suppose they are given another one. This is also standard one. Integral 0 to pi by 2. Integral 0 to pi by 2. 1 by sin x plus cos x dx. 0 to pi by 2. Integral 0 to pi by 2 sin x plus cos x dx. 0 to pi by 2 sin x plus cos x dx. When they are given this one, always this answer is root to 2. Log of root 2 plus, we can simplify, but it's sin x plus cos x, because the meaning both x are same, here. I can write root 2 into log of root 2 plus 1. Root 2 log of root 2 plus 1. You can write your answer. This is direct standard question. Again, integral 0 to pi by 2. Integral 0 to pi by 2. 1 by, see, a square sin square x plus b square cos square x. 1 by 0 to pi by 2, 1 by a square sine square, this is a square sine square x, b square cos square x, b square cos square x. Whenever they are given like this, answer is start pi by 2ab, pi by 2ab, important one, this one. 0 to pi by 1 by a square sine square x plus b square cos square x dx always equal to pi by 2ab. Directly you can write your answer pi by 2ab. No doubt you can write pi by 2ab. Sometimes they made a small change in this problem. So remember, this is the difference of this, you remember. This is the standard one, most important one also. Like this, 0 to pi by 2. 1 by a square sine square x plus b square cos square dx is pi by 2ab. Small change they will give. What is the small change? Suppose the same formula they may give integral, you can see 0 to pi. So the difference of this integral 0 to pi, integral 0 to pi, this one, x by a square sine square x, a square sine square x, b square cos square x dx. So remember, this also concept is important. If they give like this, cos square x dx. Here this is 0 to pi x by a square sine square x plus b square cos square dx. This answer will be pi square by 2ab. That's all. Pi square by 2ab. You compare the previous one, this one, just remember. Here 0 to pi by 2, 1 by a square sine square x plus b square cos square dx is pi by 2ab. 0 to pi x by a square sine square x plus b square cos square x dx equal to pi square by 2ab. It will come only pi square dx. Remember this one. Correct. These are all standard problems, right? You can remember this one. We can express the values directly. We can write the values. You can write directly. Right. Few problems we will solve that. Then after that we will come back to the formulae. Now we'll solve the problems in the next class. Again I will give the logic, like how to do the problems very quickly using this same simple concept. I can also explain. Explain these problems. Correct. Here I can tell you one more problem. I can tell you that you can follow that. One more problem. These are important because I can write this. Integral 0 to pi. Integral 0 to pi. X tan x. Integral 0 to pi. X tan x by secant x plus cos x. X tan x by secant x plus cos x dx. And also equal to 0 to pi x sin x by, if we convert sin by cos, this is x sin x sin x by 1 plus cos square x, 1 plus cos square x dx. This is 1 plus cos square x dx. If they are given like this, both are like 0 to pi only, answer is pi square by 4. Pi square by 4. This is standard problems. X tan x plus secant x plus cos x. X sin x 1 plus cos square x dx, answer is pi square by 4. Suppose if they change the limit here, this is x tan x by secant x plus cos x. Secant plus cos x. You can also remember if they do small changes here, integral 0 to pi. See, if they do small change in this problem, again I am adding integral 0 to pi x tan x by, because this is standard problems, x tan x by. If they give secant x plus tan x, secant x plus tan x they are given. Instead of cos x they are given tan x, secant x plus tan x. This is secant x plus tan x is given, or integral 0 to pi x sin x by 1 plus sin x. If I write this is sin by cos, 1 by cos, sin by cos, cos will eliminate, it will be equal to this, dx equal to, answer will be pi into pi minus 2 difference, pi into pi minus 2 by 2. by 2. This is pi into pi minus 2. You understood? Pi into pi minus, this is also pi only. Pi into pi minus 2 by 2. Pi into pi minus 2 by 2. That will be our answer. These are all standard problems. Right. Like this, if we learn this, directly we can write the answers, problems right. Now we will explain the few problems, then we will come back to that. We will solve that. Now, just many things I should explain like this, all the shortcuts I should explain. Now we will solve the problems, then we will come back to the properties again. The shortcuts we will discuss again. The next class I can discuss the shortcuts. Now if you solve a few problems now. See the problems now, I will start the problems now. You can see few problems, I will do that now. Right. Now you can see this one. Integral 0 to a. Integral 0 to a. F of x by f of x plus f of a minus x dx. This problem is given. What about this answer? F of x plus f of a minus x. A minus x dx. This is a given problem. They are asking what is the answer. If you go through the points what I have given, you will understand this. You can see, you will get f of a minus x equal to f of x. If you follow that, they are asking what about this value. I am giving standard problem here. When they are given like this, you apply here, let it be this is I is equal to, you write I is equal to 0 to a, f of x by, you write f of x plus f of a minus x, f of x by, you write f of x plus f of a minus x dx. You have taken let I is equal to, correct. So what I have done here, I have written, then you replace this one 0 to a, replace x with a minus x, f of a minus x by f of x, f of a minus x. You are replacing x with a minus x, the property. Now this will become here. I can also, if you replace that, what it comes now? This will become here. Again we will get 0 to a, f of a minus x by, this will become f of x plus f of a minus x, right, dx. So these also I add I plus I, because this one is 1, given one is 1. You have taken the given one is I, means this is 1. So this is 2, adding 1 into 2. If you add 1 plus 2, I can add 1 plus 2. If you add 1 plus 2, right. Now if you add 1 plus 2, one plus I, correct, it comes I plus I, add 1 plus I, you get I plus I. So when I have taken I plus I, add 1 plus 2, it comes I plus I is equal to, when I am adding I plus I, you will get 0 to a, the first function f of x by f of x plus f of a minus x plus f of a minus x by f of a minus x by f of x plus f of a minus x. This is x only, x. We are adding 1 into dx. This will become 2i, right? This side will become 2i. Correct. So this will become 2i is equal to, when I have taken this I plus I, 2y is equal to 0 to a. I can add numerators f of x plus f of a minus x by f of x plus f of a minus x dx. So then these two are same, right? This will be, I can write this is equal to integral 0 to a 1 dx. So it will become x. Integral 1 dx is 0 to a. This will become a minus 0 a. 2y is equal to a, it comes, right? 2y is equal to a. You will get 2y is equal to a, then I is equal to a by 2. That will be your answer, right? I is equal to a by 2. Correct? Answer is I is equal to a by 2. This will be required answer. Like the combination, like the problem, sometimes they may give problem in that combination. 0 to 2, something. You can do that, easily can do, right? You can remember this as the standard problem. We got it here. Just applying this. Just you replace x with a minus x. Then you added 1 plus 2. Then we got integral 0 to 1 dx is x. Apply the limit. 2i is equal to a. I is equal to a by 2. For example, they are given the problem. For example, they are given example problem 0 to, they are given 0 to 4. Think they are given problem integral 0 to 4. Integral 0 to 4. Anything they are given here. Suppose x, the function, the related function they are given. 0 to pi by 4 they are given. Root of 4 minus x they are given. X plus root of 4 minus x. Root x they are given like this. Think when they are given like this, you can compare with this. Root of 4 minus x is given. Root of 4 minus x. If you apply the previous formula, you can check that. Replace x with 4 minus x. It will be root x. This will be root 4 minus x. When they given our answer is a by, this is a value. 4 by 2. Answer will be 2. Compare the previous one. 0 to 4 root of 4 minus x by root x plus root of 4 minus x dx. Correct. I can write this. Answer will be 4 by 2. Suppose they are given another one. They are given 0 to 5. 0 to 5 they are given. They are given root x plus, I'm giving an example this. Root x plus root of 5 minus x dx. Answer will be 5 by 2. A value is 5. 5 by 2 it comes. Correct. Like this you can solve the problems. Quickly you can solve the problems. I hope you understood this right. Is it clear? Is it clear? I understood that. Is it clear? Should I repeat anything? If you want to repeat, I can repeat that. Then fine. Yes. No, 5 by 2. Then you can see the next problem. You can tell the answer here also, this one. Right. Same, using the same concept, you can write this one. You can see the next one. Integral. The problem is I is equal to integral 0 to 1. Integral 0 to 1. X into 1 minus x whole power n. 1 minus x whole power n dx. 0 to 1 x into 1 minus x whole power n dx. This is 0 to 1. The limit 0 to 1. X into 1 minus x whole power n dx. So what about this value? X into 1 minus x whole power n dx. So when they are given like this, no, this is because the questions are concept understanding questions, this one. These are all questions, concept understanding questions I am doing now. 0 to 1 x into 1 minus x whole power n dx. When I have taken like this, again apply the formula. 0 to a, f of x dx equal to 0 to a, f of a minus x dx. I can apply this formula. It's useful here. Because it's difficult to expand 1 minus x whole power n. Binomial theory. Instead of that, if I use this, I can interchange the power. See, now I can write this one. We can write the power, right? I can write the power here, you can write. So what can I do now? You can see that I can interchange, means the value I can interchange. I can write the value of this, right? Now you can replace x with 1 minus x. I can write 0 to 1, replace x with 1 minus x. In the place of x, you write 1 minus x. 1 minus of 1 minus x. whole power n dx. So this will become 0 to 1, 1 minus x into, here this will become x power n. Correct. Then it will be easy for you to expand 0 to 1. This will be x power n minus x. This is x not n. This is x only. X into x power n. This will become x power n plus 1 dx. If I do integration for this one, so now you can see, if I do integral of this, I can get, which is equal to, I can write, when I am taking integral of this one, x power n, it comes x power n plus 1 by n plus 1. Right. We can express like this, x power n plus 1, x power n plus 1 by n plus 1 minus x power n plus 2 by n plus 2, limits I can apply 0 to 1, n plus 2. Apply the limits, you will get 1 by n plus 1 minus 1 by n plus 2. It will come like this, 1 by n plus 1 minus 1 by n plus 2. If you want, you can simplify, you can stop here, or if you simplify also, this will be n plus 2 minus n minus 1 by n plus 1 into n plus 2. Then I can write, this will be 1 by n plus 1 into n plus 2. Like this you get the answer. Sir, can I remember the standard? Yes, you can remember the standard problem. Because if they give 0 to 1, if they give problem with n value only, right? Suppose you can see this problem, if they give with n value, this 0 to. Suppose they are given the problem, then you can remember 0 to 1, they are given x into, so 0 to 2 also they can give anything, I can write here. This is 1 minus x whole power, they are given 5 dx. Then your answer will be 1 by 5 plus 1 into 5 plus 2. 5 plus 5 plus 2, it will be 6 into 7, 1 by 42, correct? 1 by 42 it comes. Sir, can I change this value? You can change this value here. If you change this value, can I continue like this? If you change this value, suppose 0 to 2 you have written. 0 to 2 x into 2 minus x it comes. It comes 2 minus x. Correct, at that time. But doing the problem will be here. Almost it will be same here, right? You are writing here, you are replacing that, you are writing here. 0 to 1. So you can remember like that, the concept if you learn, any problem you can do here. Remember the concept, you can do any problem, right? Now, you can see that. After that, another problem I can do now. I hope you understood this one. Is it clear? This concept is clear, right? Right. Next one. Suppose they are given here integral 0 to pi. Integral 0 to pi. They are given x into f of sin x dx. What about this answer? 0 to pi. X into f of sin x dx. X into f of sin x dx. Suppose they are asking this problem, x into f of sin x dx. Options you can see. Suppose 2 pi is one of the option. Second option, 0 to pi by 2, 0 to pi by 2, f of cos x dx. F of cos x dx. In third option, 0 to pi into 0 to pi by pi into 0 to pi. Third option, 0 to pi, f of cos x dx. F of cos x dx. And fourth option, pi into 0 to pi, f of sin x dx. Fourth option, pi into 0 to pi, f of sin x dx. F of sin x dx. Think about the option, which option is suitable here. Think this one, which are suitable here. 0 to pi x into f of sin, 0 to x into f of sin x dx. F of sin x dx. Think which is suitable. Think. I will explain. You do that. You think 0 to pi x into f of sin x dx. In what way I can simplify this? Right. Which option is correct? X into 0 to x into f of sin x dx. These are the options. 2 pi 0 to pi f of cos x dx, pi into 0 to pi f of cos x dx, pi into 0 to pi f of sin x dx. This one, can you write this one? Equal to 0 to pi, replace x with pi minus x. Pi minus x into f of sin of pi minus x. Sin of pi minus x dx. Sin of pi minus x, you know, that will be sin x only. It will come 0 to pi. This will become pi minus x into sin 180 minus x sin x only. I can write like this. Right. F of sin x dx. Now when I have taken like this again, you apply this property here. This is 0 to pi. 0 to pi f of sin x dx. But you see, what way I can replace this in terms of pi minus x, 0 to pi, pi minus x f of sin x dx. So can you simplify this? Any changes can I do? 0 to pi minus x, the function. So we got pi minus x, x into f of sin x, x into f of sin x. You see, you take, this is I. The beginning you take, let I is equal to, this I is equal to, you take, to understand I'm telling. You take I is equal to. This one, can I split this 0 to pi f of, because to understand I take an I is equal to this. This is 0 to pi into f of sin x dx, plus I can write this is a minus 0 to pi x into f of sin x dx. F of sin, this is I only, right? We have I is equal to f of sin x dx. If I transfer this side, this is also I can write 0 to pi. This is pi into f of sin x dx minus this is I have done. Transfer that side. You will get 2y is equal to 0 to pi. Pi I can write outside, 0 to pi f of sin x dx. Correct? I have taken 2i equal to this. From this I is equal to pi by 2, 0 to pi f of sin x dx. It will come like, but that answer is not there. You can see that. I got this one. I equal to pi by 2, 0 into pi f of sin x dx. We have only pi is here. That option I can't. Fourth option is not correct. Second or third option, f of 0 to pi f of cos x dx, that is not correct. So that is not correct. You can see that. What can I do now? The 0 to, what can I do? The changes here. Anything can I do the change? Because fourth option is not correct. Third option is not as for this. You'll get either 2 pi or 0, first or second option. So first or second option to get that, because we have pi by 2 is here. Correct. Second option, can you think any changes can I do here? So why? Because either first or second means I want 0 to pi by 2. So replace x with something, pi by 2 minus x. Can I replace x with pi by 2 minus x? Can you try that? Replace in this problem, just 0 pi by 2, 0 to pi f of sin x dx we have. So you can replace x with, here you can try pi by 2 minus x, for example, you can replace, consider pi by 2 minus x is equal to t. Let pi by 2 minus x is equal to t. Then x will become pi by, you will get t plus x will become, you will get x is equal to pi by 2 minus t. Correct. I can write this one. Let it pi by 2 minus x is equal to y, because I want to get cos here. I am expecting answer maybe first or second. To get here, replace x with pi by 2 minus x. Suppose if we get this one, pi by 2 minus t will be x. Correct. If we do this one, the changes you can observe here. What do you observe here? When I have written, in the place of what is pi, I can write here. See, pi by 2. Pi by 2 means I can write, this will be, always you will get, the value will get pi by 2. The changes, if I do that, the changes in the problem, what can I replace here? Sine of pi by 2 into 0 to pi. F of, can I write, sine of, in the place of x, pi by 2 minus t. Sine of pi by 2 minus t will be cos t. It will become cos t. Correct. Understood. You will get cos t. Pi by 2 in the place of x, you write pi by 2 minus t. Sin pi by 2 minus t will be cos t. What about dx? Pi by 2 minus x is equal to t I have taken. So dx is equal to minus dt it comes. Dx equal to minus dt. I can write minus dt. Correct. I can express minus f of cos t. I have taken minus dt. Because I have taken the substitution here. Minus dt. I can change the limits also, right? When I am doing this, I should change the limits also. Integral. Suppose you have taken 0. 0 means t will be pi by 2. Correct? Because I am changing the limits. When x equal to 0, t equal to pi by 2. Then when x equal to pi by 2 minus pi, it will be minus pi by 2. It will come minus pi by 2, right? Correct? You will get minus pi by 2 to minus pi by 2. When I have taken x equal to pi, it will come minus pi by 2. Pi by 2 to minus pi by 2, f of cos t minus dt. See that the thing to simplify the answer, when I have taken due to minus, I can interchange the limits. You will get due to minus, this will become f of the cos t dt. So I can write now. So what can I write now? You will get minus dt. If I interchange the limits, pi by 2. If I interchange the limits, this minus will become positive. I can write minus pi by 2 to pi by 2 f of cos t dt. F of cos t dt. Right. See that now, f of cos t dt now, minus a to a. F of cos t dt. What about this function I can consider? Can I consider that function? If we consider this one, you can see that the options, you go through the options what are given. See the options here. This is option. Second option, sorry, I forgot here. This is pi also is here. In second option, pi into 0 to, first option 2 pi, second option pi into 0 to pi by 2 f of cos x dx. This is second, pi is missing here. I forgot, sorry. Pi into 0 to pi by 2 f of cos x dx. That is the second option. Now when I am doing this, see this, when I have done this part, I got pi by 2 minus pi by f of cos t dt. Now you can check here. When we got this, right, when I got this, verify even or odd function. This is even function. This is even function, right? The function is even function. Since the function is even function, the function is even function, right? Since the function is even function, this is right, pi by 2, right? Since the function is even function, I can write this one 2 into pi by 2, because since the function is even, right? So the function is even, I get 2 into pi by 0 to pi by 2 f of cos t dt. Function 2 into 0 to pi by 2 f of cos t dt. Right. So we will get 2 to cancel. It will be pi into 0 to pi by 2 f of cos t dt. Right. We get like this, right? F of cos t dt. Then you can observe that one. The last step I am going to explain here. This will come. Right. This one 0 to. When I have taken the simple, since it's even function, I have written this concept. What I have written here? 2 into pi by 2. This 2 will get cancelled. Pi into 0 to pi f of cos t dt equal to pi into 0 to pi f of cos t dt. Second option is correct. So many concepts are there in this problem. Please observe that. This model is important. Second option is correct. This is your answer. Second option is correct. Pi into 0 to pi by 2 f of cos x dx. Try to do one more time this problem. So you can see I am going to explain one more time. The given problem is 0 to pi x into f of sin x dx. Options are 2 pi, pi into 0 to pi by f of cos x dx, and pi 0 to pi f of cos x dx, pi into 0 to pi f of sin x dx. Replace x with pi minus x. Then pi minus f of sin x dx. Then I have taken after replacing this. So here 0 to pi minus x f of this sin 180 minus s sin x. You expand pi into f of sin x minus 0 to pi x into f of sin x. I have done that. After that we have done this one f of this is pi into f of sin x dx minus I. Transfer I that side. 2i is equal to pi into 0 to pi f of sin x dx. Again now here the I is equal to I have written. Whenever I is equal to pi by 2, 0 to pi f of sin x dx. But in the option this answer is not there. Then I thought some combination. Second, third and fourth options are not your answers. Either first or second. In second cos x is there. How to get that? Pi by 2 minus, consider pi by 2 minus x is equal to t. Pi by 2 minus t equal to x. Dx equal to minus dt. You simplify all this. Finally you will get this one. Pi into 0 to pi by 2. After getting simplification, you will get, since even function, I can write since it's even function, pi by 2 and minus pi by 2 pi by f of cos t. This is cos t dt, not dx dt. Since even function, I get 2 into pi by 2, 0 to pi by f of cos t dt. 2 to get cancelled, you get pi into 0 to pi by 2, f of cos t dt. So this is the required answer, f of cos t dt. F of cos t dt, this one dt. So that is the required answer. So with this I have completed many concepts today. In the next session I will continue with more number of important concepts. I will continue. More number of important concepts I will continue. In this problem, if you have any doubt, please ask me. Is it clear? Clear this one. Right. Okay. Then fine. You're receiving this right? Then see you in the next class. Then bye.